Hello students, welcome to today's lesson. I am Brukalo. Okay, in last week discussed about the new chapter, carboxylic acids. You know what I mean by carboxylic acid means. Again, what I mean by organic chemistry means. Also discuss about the physical properties of carboxylic acid, the IUPAC and common names of carboxylic acid, and also the chemical properties of carboxylic acids. This is the use of carboxylic acid. By the way, this carboxylic acid used as a solvent and a starting material for the preparation of acetates and acetic anhydride. Also, carboxylic acid, very important, especially vinegar, contains about 8 up to 10% is acetic acid, which is very important for many food items. Again, you know aspirin. Aspirin is a common painkiller. Therefore, these aspirins are formed by the acid known as acetic acid. By the way, this is acetic acid, and salicylic acid. This is salicylic acid. Therefore, salicylic acid combined with acetic acid by using of a catalyst produces aspirin. Aspirin is very important, common painkiller. The other name of aspirin is acetyl salicylic acid. Therefore, carboxylic acid used for the productions of aspirin. Again, aspirin contains what? Ester and carboxylic acid functional groups. By the way, this is aspirin. Look, the functional group is COOH. COOH is carboxylic acid. Therefore, aspirin contains COOH functional group. Again, look this one, RCOO. RCOO. This is RCOOH and RCOOR. This one is ester. Ester is contains COO functional group. Carboxylic acid is COH acid. Therefore, aspirin contains ester and carboxylic acid functional groups. Carboxylic acid used for making soaps, detergents, and shampoos. And finally, they are used commercially, the raw material for the production of synthetic odors and flavors. Therefore, simply carboxylic acid used for the production of synthetic odors and also a good flavor. This is the use of carboxylic acid. The other subtopic is esters. Esters general formula RCOOR prime. This is the ester functional group. Source of esters. Many esters are pleasant smelling substance, a good smell, and are responsible for the flavor and the fragrance of many fruits. For example, apples, pears, banana, pineapple, and strawberry. Fats, wax of plants or animals, the origins of all are esters. Therefore, esters are the responsible for a good flavors. Many esters are found in flowers. The structure and nomenclature of esters. Esters are derivatives of carboxylic acids in which the hydroxyl group or known as OH group of carboxylic acid has been replaced by the alkoxy group. That means, look this one, RCOOH. This is carboxylic acid. This carboxylic acid, the OH group, this is OH group. This OH group is replaced by alkoxy. Alkoxy means RCOOR prime. This is alkoxy group. Therefore, the carboxylic groups of OH has been replaced by alkoxy group produces ester. Therefore, ester contains 2 R. This R, this R, 3 possibility. Because of the acid portion, discussed about it last time, R may be hydrogen, R may be alkyl, R may be aryl. But in the case of R prime, two possibilities, alkyl and aryl, because this is the alcohol portion. In the alcohol portion, alkyl and aryl. In the acid portion is three possibilities, hydrogen, alkyl and aryl. Carboxylic acid reacts with alcohol, it produces ester. Look, the carboxylic acid group, this OH group, OH, in carboxylic acid removing of OH, from water removing of H, OH and H, replaced removing of water, finally produces RCO. RCO, this portion, acid portion, the acids are removing of OH. Look this one, R prime OH, R prime OH, removing of what? Removing of H. What is left? R prime O. This R prime O is alcohol portion. Therefore, this is what? Ester. Ester, how many portion? Two portion. What are there? One is acid portion, the other one is alcohol portion. Therefore, this process, by the way, known as what? Esterification. The production of ester plus what? Plus water. This water is from carboxylic acid, OH, with alcohol, H. Water can be formed. Therefore, this is ester. Ester two portion, acid portion and alcohol portion. Therefore, carboxylic acid reacts with alcohol. It gives ester plus water. The process is what? Esterification. Names and the formula of some common esters. Look at the name of this one. CH3CO OCH3. This portion is acid portion. This one is alcohol portion. In naming, first write the alcohol portion. How many carbon? One carbon. Therefore, methyl. Methyl. Two carbon, ethyl. And so on. Therefore, starting from first always the alcohol portion. How many carbon? One carbon, methyl. Two carbon, ethyl, propyl, and so on. Methyl. Look this one. How many carbon? One, two. One, two. Two carbon. In the case of common name, two carbon is acetic acid. This one. Acetic acid. In the case of common name, this one is acetates. Acetic acid replaced by acetate. Therefore, methyl acetate or methyl ethanoate. Why ethanoate? Because it is ethanoic acid. The acid name is ethanoic acid. Look this one again. This is the acid portion. This one is alcohol portion. Students, the alcohol portion, how many carbon? Two carbon. One carbon, methyl. Two carbon is what? Ethyl. Look, ethyl, ethyl. Next, common name and IUPAC name. In the case of common name, how many carbon here? One carbon. You discussed about it last time. What is the common names of the first monosaturated carboxylic acid? Formic acid. Converted into formate. The IUPAC name is what? Methanoic acid. Converted into methanoate. Similarly, this one is alcohol portion. This is acid portion. The alcohol portion, two carbon, ethyl, ethyl. Because of two carbon acid, acetic acid converted into acetate, ethanoic acid converted into ethanoate. This is the names of ester by using of common and IUPAC system. Physical properties of ester. One is odor. Have pleasant smell. By the way, the odors of esters are, it is a pleasant smell. The odor of many fruits and flour result from the mixture of carboxylic esters. The second one is boiling point. The boiling point of esters increase with increasing molecular mass. By the way, this is not for only ester. All organic compounds. The carbon number increases, the boiling point also increases. This is similar again in ester. Branched chain esters have lower boiling point than a straight chain. You know, in alkane, alkene, alkyl, alcohol, aldehyde, and so on. Always the straight chain higher boiling point than the branched chains of comparable or similar molecular masses. Esters have lower boiling points than carboxylic acids and alcohols. By the way, in boiling point, carboxylic acid greater than alcohol. Why? Because carboxylic acid with carboxylic acid, it produces a dimer. Dimer means one molecule with another molecules of acid, 2 times hydrogen bonding can be formed. Alcohol with alcohol forms hydrogen bonding only 1 times. But ester with ester not forms hydrogen bonds. Ester with ester is not forms hydrogen bonding. Therefore, in boiling point, esters have lower boiling points than carboxylic acids and alcohols of comparable molecular mass. This is because ester molecules cannot form hydrogen bonds with each other. Each other means ester with ester not forms hydrogen bonding. The third one is solubility. Esters of lower molecular masses are fairly soluble in water. Esters can form hydrogen bonding. With what? With water, not with ester. Therefore, ester forms hydrogen bonding with water molecules. The solubility of ester in water decreases with increasing molecular mass. Chemical properties of ester. The first one is hydrolysis. The general reaction for acid catalyst, look this one, RCOOR prime. R prime is alcohol portion, R is acid portion. Ester plus water, by using of acid catalyzed, this is acid catalyzed, it gives RCOOH plus R prime OH. This is what ester, look, RCO with OH group. R prime O with H group produces, this one is carboxylic acid, this one is alcohol. Therefore, ester with water, this process is hydrolysis, splits, breakdown. In this case, split or breakdown by what? By water. Ester with water, it gives carboxylic acid plus alcohol. The reactions are reversible. Look at this reaction. This is ester, methyl benzoate, ester plus water. Simply benzyl group CO, benzyl group CO, OH. Simply these bonds are break, CO connected with OH, CH3O, this one, CH3O connected with H. Simply it gives benzoic acid and methanol. Therefore, ester plus water by acid catalyzed, it produces acid plus methanol. Esters also undergo base catalysis. The previous one is acid catalyzed. Ester plus water by using of acid catalyzed, carboxylic acid and alcohol can be formed. This is what? In base catalyzed. To give salt of carboxylic acids and alcohols. Base catalyzed esters hydrolysis is called saponification. This process is saponification, irreversible reaction, one-way reaction. Therefore, this is a salt. This is soap, the general formula for soap. Therefore, sodium hydroxide, this is sodium hydroxide, strong base, or potassium hydroxide is possible. Therefore, sodium hydroxide and potassium hydroxide are the bases generally used for hydrolysis. This process is what? Saponification. Why saponification? Because of the production of soap. Therefore, soaps are what? Soaps are salts. What is the byproduct? The byproduct is alcohol. By the way, for soap production, the byproduct is alcohol. This is what? Ester. Ester. Therefore, esters are very important for the productions of soap. Ester with what? Sodium hydroxide or potassium hydroxide. It produces soap plus alcohol. Soaps are chemically salts. Students, what is the process for this one? Saponification. This is base catalyzed ester, saponification. Acid catalyzed ester, carboxylic acid and alcohol. Therefore, this one is salt plus alcohol can be produces. But what types of base can be used? Strong base such as sodium hydroxide or potassium hydroxide. The other points reduction. Reduction means addition of hydrogen. Look, esters are reduced to primary alcohols by special reducing agents like lithium aluminum hydride. This is lithium aluminum Al hydride, lithium aluminum hydride. Look this one. RCOOR prime is what? Ester. This one is ester. Lithium aluminum hydride, acid catalyzed H+, it gives alcohol and alcohol. But this alcohol is always primary alcohol. Primary alcohol. Primary alcohol means the general formula RCH2OH. A carbon atom connected with OH, connect again, another carbon group is primary alcohol. Therefore, ester, by using of a special reducing agent like lithium aluminum hydride, it gives two alcohols. But one alcohol is always primary alcohol. For example, CH3, CH2, CH2, OH. Look, this carbon. This carbon is connected with OH. Again, this carbon connected only one R group. All this is R. Therefore, this carbon is connected with how many carbon group? Only one carbon group is primary alcohol. Look this one. This is methyl pentanoate. Already ester. This ester produces one pentanol and methanol. One pentanol, this one. Look, this is CH2H. Already this group is R. Already this carbon is primary carbon. Therefore, always ester treated by lithium aluminum hydride with special reducing agent is lithium aluminum hydride and H+, it gives primary alcohol and another alcohol as a product can be formed. Preparation of ester, already previously discussed. Look this one. Students, what is the general name of this one? R, already here C. RCOOH. This is what? Carboxylic acid. R prime OH. This is alcohol. This is carboxylic acid. By using of acid catalyst, most of the cases sulfuric acid. Sulfuric acid is very important for as a catalyst. Therefore, carboxylic acid reacts with alcohol, the presence of catalysts like sulfuric acid, it gives ester plus water. The carboxylic acid removing of what? OH. Look, this OH. This OH is removed from the acid portion. This H removing so from the alcohol portion. Therefore, acid portion removing of OH. Alcohol portion removing of H. OH with H produces water. Waters can be formed from the carboxylic acid removing of H. Alcohol removing of H finally produces water. What is left? RCO. R here C. RCO. This one. RCO. RCO. This R prime with O connected with this one. This is ester. Please, students, this one is acid portion. This is alcohol portion. Therefore, this process is called esterification. Therefore, esters can be synthesized by heating a mixture of carboxylic acid and alcohol in the presence of acid catalysts such as sulfuric acid. This reaction is called what? Esterification reaction. Uses of esters. Esters used for oils and fats. Esters are very important for the production of oils and fats. Nail polish, varnish, paint, gums are formed by esters. Because of their pleasant, fruity smells, esters are used in making artificial flavors and perfumes. Some common fruits and the esters are responsible of their flavor. For example, apple. This is apple. This one is pineapple. Orange here. Banana again. Therefore, apple, orange, banana, pineapple contains ester. For example, apple is this one. This apple is contain ester. What is the name of that ester? Ethyl isovalerate. Banana, for example, banana contains an ester. The name of the ester is known as isopentyl acetate. Orange, for example, octyl acetate. Therefore, different fruits contains ester because of their pleasant smell. The other point is fats and oils. Fats and oils belongs to a class of biomolecules called lipids. By the way, both fat and oils are lipids. They are triesters. By the way, the structure of fats and oils are triesters. 3 ester in one structure of glycerol, which are collectively known as triglycerides or triacyl glycerols. The difference between fat and oil depends on their physical state. By the way, the physical states of fat and oils are not the same. Fats are semi-solids. Oils are liquid at room temperature. Therefore, the same structure. Both contains 3 esters in one structure. What is the difference? The difference is the physical states of fat and oils. What is fats? Fats are semi-solids. What about oils? Oils are liquids at room temperature. But both are insoluble in water because both are non-polars. The structures of fats and oils. Fat and oils are what? Triester. Tri is 3. 3 ester molecules in one structure. Variation is in the structure of fat and oils occur in the fatty acid portion of triglycerides. Look this one. This is a general formula, structural formula of fat and oils. Look, RCOOR ester. RCOOR, another ester. RCOOR ester. How many ester? 3 ester. Therefore, this is the general formula of fat and oils. The only difference is in R portion, R1, R2, R3. Maybe forms carbon-carbon double bond or carbon-carbon single bonds. Hardening of oils. Oils can be converted into fats. By the way, oils are contains carbon-carbon double bond. Fats are carbon-carbon single bonds. Therefore, oils can be converted to fats by addition of hydrogen or hydrogenation at high pressure in the presence of the catalysts known as nickel or palladium PD as a catalyst. This process of converting of what? Oils to fats, liquids to solids, semi-solids. Therefore, this process of converting oils to hard fats is known as hardening of oils. For example, look this structure or equation. This one is oil. This is fat. All are the same. The only difference, look, carbon 17, H33, H35. The difference is to hydrogen. Because of that, carbon 70 means carbon, 70 times, but in one position is carbon-carbon double bond. Because of carbon-carbon double bond, 2 hydrogens are less. For example, carbon double bond, carbon, hydrogen, 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 hydrogen. Let's take single bond. Carbon, carbon, H, 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 H. What is the difference? 1, 2, 3, 4 hydrogen. How many hydrogen here? 6. What is the difference? 2 hydrogen. Because of what? Double bond. Double bond converted into single bond, additionally 2 hydrogens can be added. Therefore, here 17 carbon, 70 carbon. 33 hydrogen, 35 hydrogen. Therefore, in one ester, 2 hydrogens are less because of carbon-carbon double bond. Because of carbon-carbon double bond, 2 hydrogens are less, 2 hydrogens are less, 2 hydrogens are less, 3H2 can be used, 3 hydrogen. By using of nickel, high pressure, Again, nickel or sometimes known as PD, palladium. It gives fats. 33, 35, 33, 35, 33, 35. Total 6 hydrogen can be added. Because of the addition of hydrogen, this process is hydrogenation. Because of the addition of hydrogen, this process is hardening of oil. In hardening of oil, what types of catalysts can be used? Nickel or palladium. Soaps and detergents. You know, all of you, what I mean by soap and detergent means. Soaps are sodium or potassium salts. Soaps are salts. By the way, soaps are chemically salts. Soaps are salts. Therefore, this is triester. Triesters. Therefore, RCOOR, ester, triesters, fat and oils. Fat and oils are used for the production of soap. By using soap, sodium or potassium, strong bases, sodium hydroxide or potassium hydroxide. Therefore, RCOOR, and so on. This is triester. Triester treated by a strong base, such as sodium hydroxide or potassium hydroxide, it produces soap. This is a soap plus alcohol. This alcohol contains 3 OH group, OH, glycerol. Glycerol. The other name of glycerol is what? 1, 2, 3. Propantriol is possible. 1, 2, 3 propane. Triol. This is what? The byproducts of soap is glycerol or known as alcohol. This process is what? Already discussed. Saponification. The production of soap. What types of base can be used? Strong base such as sodium hydroxide. This is detergents. Detergents are synthetic substance which is used as substituent to soaps. Both soaps and detergents are amphipathic nature. Amphipathic nature. The carbon 12 up to carbon 18, when the production of soap, alcohols can be used. How many carbon alcohol? 12 carbon up to 18 carbon alcohols are used. Converted into the salt. Look this equation or reaction. CH3, CH210. CH210 means already 10 carbon plus 1, 11 plus 1, 12 carbon alcohol, lauryl alcohol, treated with sulfuric acid. It gives this sulfate, again treated by strong base, sodium hydroxide, finally produces these detergents. By the way, look in the case of soap. This is soap. RCOO minus Na plus. These are a number of carbon group, 70 carbon, and so on. These are contains long chains of carboxylic acid. By the way, a carboxylic acid contains more carbon is known as fatty acid. Fatty acids are long chains of carboxylic acid. Similarly, in the case of detergent also, a number of carbon here, long chains of carbon is present here. Therefore, the only difference between soap and detergent, in the case of detergent, it contains what? Sulfates. In the case of soap, O minus Na plus. Therefore, both soap and detergents are soap. Look this one. RCO means RCO O minus Na plus. R is what? R is a number of carbon. Therefore, carbon, 70 carbon and so on. This is CO O minus Na plus. For soap, this is polar. This carbon group, this carbon group RCO O minus Na plus. This group is polar. R means what? Carbon, a number of carbon group. This is what? R group is what? Non-polar. In one molecule contains polar and non-polar. The polar group is the head one. The head one is polar. This one is R group. The tail part is non-polar. Therefore, soap contains polar and non-polar. The polar portions are soluble in water. The non-polar portions are soluble in non-polar solvents like oil, fat, and so on. Therefore, this one is oil soluble, fat soluble. This portion, the head one, is water soluble. Similarly, in detergent, polar and non. Because of that, both soaps and detergents are amphipathic nature. Amphipathic means it contains both polar and non-polar. Soap contains polar and non-polar. Detergents are contains polar and non-polar. But detergent, because of sulfates, is more preferable in hard water. Which one is more preferable? Detergents are more preferable. Why? Because detergents, because of sulfate ion, easily soluble, especially in hard water. What types of ions are present? Magnesium and calcium. Magnesium and calcium are easily soluble in sulfates. Therefore, which one is more preferable? Sulfates are more preferable in hard water. Therefore, detergents are more advantageous in hard water because of the sulfate portions. But simply, in the case of detergent or alcohol, it contains RCO, O minus, Na plus. This is which portion? In a soap portion. Therefore, simply this carbon group, carbon, two portion. One is non-polar, the other one is polar. The polar portion is water soluble. The non-polar portion is oil soluble. Because of that, because of different indes, polar and non-polar, the polar water soluble, the non-polar water insoluble or hydrophobic portion. This one is hydrophobic. Both detergent and soaps are contains hydrophobic portion. Hydrophobic, water insoluble, water repellent. Water soluble is hydrophilic portion. This is the end of this topic. ተማሪዎች የ11ኛ ክፍል የመጨረሻ ዩኒታችን ይሄንን ይመስል ነበር። ያው በተቻላችሁ መጠን ያነበባችሁ እንደሆነ ምንም ጥርጥር ያለኝ አይመስለኝም። ስለዚህ እናንተ በቤታችሁ መጽሐፍቶቹ ታገኛላችሁ። እነሱ ማንበብ አለባችሁ። ታላላቆቻችሁን ጓደኞቻችሁን በስልክም እየተደዋወላችሁ ቢሆን እየጠየቃችሁ መረዳት ይኖርባችኋል። ስለዚህ ቤታችሁ ተቀምጣችሁ ለራሳችሁ ጊዜ ሰጣችሁ ብዙ ነገሮች ማድረግ ይኖርባችኋል። እባካችሁ በጣም ከባድ ሁኔታ ካልገጠማችሁ በስተቀር ከቤት ባትወጡ ይመከራል። ስለዚህ ቤታችሁ ተቀምጣችሁ የሚያስፈልጓችሁ ነገሮች በማድረግ ማንበብ ይኖርባችኋል። ቤት ውስጥ መረዳዳት እና ሁሉም ነገር የምትባሉት ነገሮች መስማትና መከታተል ይኖርባችኋል። እስካሁን ሳስተምራችሁ የነበርኩት መምህር ብሩክ አለሙ እባላለሁ። መልካም ጊዜ ይሁንላችሁ። አመሰግናለሁ።